For years, the whole story of AI has been about one thing: size. Bigger models, bigger data, bigger budgets. But what if that's just the wrong story? Today, we're diving into some fascinating new research that suggests the future of AI isn't some single giant brain. Nope, it's more like a brilliant conductor leading an orchestra of specialists. And that really brings us to the core question, the one that's driving the entire industry right now. For so long, it's been a flat-out race to build the biggest, most powerful AI model possible. But this new research, it's asking a different question. What if we've been missing the point? The reality is, this current approach of creating these monolithic, one brain to rule them all AIs is insanely expensive. We're talking billions and billions of dollars. And for all that cash, they're starting to hit a wall, especially when you throw really complex, multi-step problems at them. So let's get into what the researchers are calling AI's billion-dollar problem. And it's not just about the upfront cost to build them. It's about how much they cost to run and, more importantly, their limitations out in the real world. And hey, don't just take my word for it. The source paper from NVIDIA and the University of Hong Kong puts it pretty bluntly. Even our best and brightest large language models are, and I'm quoting here, of limited utility in complex agentic tasks. Now, agentic tasks is just a fancy way of saying stuff that needs multiple steps of reasoning and action, the exact kind of thing we actually want AI to help us with. The point is, the current strategy, it has a ceiling.
Right. So if the giant, all-powerful soloist isn't quite cutting it, what's the alternative? Well, this is where the paper introduces this beautiful, simple, and incredibly powerful analogy: the orchestra. Just look at this. It lays out the two approaches side by side perfectly. On the left, that's the old way, one massive model trying to be a master of all trades. And on the right, you've got this new idea, a smaller, smarter conductor model whose only job is to delegate tasks to a whole team of specialists. This is the big idea they call the orchestration paradigm. The core concept is that real, flexible intelligence doesn't just come from one giant brain. It emerges from a team. The orchestrator is like the team captain or the project manager. It's the conductor who knows exactly which specialist to call on for each little part of a big, complicated problem. And as you can see here, the orchestrator has this whole suite of tools at its disposal. And we're not just talking about a simple web search or a calculator. It has other powerful AIs in its orchestra. For a tough math problem, it can call on a math AI. For a coding task, a coding AI. And here's the kicker. For general reasoning, it can even call on one of those massive frontier models. But, and this is key, only when it absolutely has to. Okay, this all sounds great in theory, but how do you actually teach an AI to be a good manager? I mean, you can't just tell it, hey, delegate more. You have to train it. The training is built around this incredibly elegant loop. First, the orchestrator reasons about the problem at hand. Then, it acts by calling the tool it thinks is the best fit for the very next step. And finally, it observes the result it gets back from that tool, updates its plan, and just starts the whole loop over again until the job is done. Simple, right? Now, here's the secret sauce. The really clever part is how this AI learns what the best move actually is. See, it's not just about getting the right answer. The researchers designed this awesome reward system that's constantly balancing three different, and sometimes competing, goals. Okay, so reward number one is the most obvious one: correctness. Did you actually solve the problem? This is the baseline, the fundamental goal. You have to get this right. But here's where it gets really smart. The second reward is for efficiency. Every tool it uses has a cost, in both time and money. So the orchestrator gets rewarded for finding the cheapest, fastest path to the right answer. It literally learns not to call up the big, expensive tool when a smaller, cheaper one will do the trick just fine. And the third reward, this one's all about alignment and user control. You can actually tell the system to prefer certain tools or to avoid others. Maybe you want to prioritize privacy and use a local search tool. Or maybe you're on a tight budget and want to minimize cost above all else. The orchestrator learns to adapt its strategy to follow your specific instructions. So you've got this small AI conductor, and it's trained to be correct, efficient, and obedient. So how does this new kid on the block actually stack up against the giants? Well, the results are pretty jaw-dropping. This is the multi-billion-dollar question, isn't it? The researchers built an 8 billion parameter orchestrator model. Now, for perspective, that is tiny in today's world. So how could it possibly compete with a Titan, a top-of-the-line frontier model that, by the way, was given access to all the same tools? Well, just look at this. On a benchmark of extremely difficult questions, they call it humanity's last exam, the little Orchestrator 8B didn't just compete, it won. It scored 37.1%, actually outperforming the much, much larger frontier model. I mean, this is a total David and Goliath story playing out in real time. But wait, it gets even crazier when you look at the cost. The average task solved by our little Orchestrator cost just over 9 cents. Now, get ready for this. Compare that to the giant model. That exact same task cost over 30 cents on average. Let that sink in for a second. The Orchestrator model was not only more accurate, it was over 2.5 times cheaper. Better and cheaper. That's the holy grail in tech. So what this all points to is a fundamental shift in how we think about building AI. The big takeaway here isn't about building ever larger brains, it's about building smarter systems.
So why does this matter so much? Because it opens up a whole new, more sustainable path forward for AI. It means powerful AI doesn't have to be locked away by the few companies that can afford to build it. It can become way more efficient and accessible to everyone. This research proves that a smart strategy of collaboration is more powerful than just brute force. It shows that a small, well-trained model can absolutely punch far, far above its weight. And that leaves us with one big final question to chew on. For decades, we've been chasing this idea of a single, all-knowing artificial general intelligence. But this research, it suggests that maybe true, powerful intelligence, the kind that can actually solve the world's hardest problems, isn't a monolith at all. Maybe, just maybe, it's an orchestra.